Hello, I'm Sam and I'm going to show you my flocking tool. Just ignore that for now. There is a bug in my script. Hello, I'm Sam and I am going to show you my flocking script. So when you open up the script, you are greeted with this box here and a cube now in the middle. First thing you want to do is put a wireframe so you can see through it. And we're going to just walk through. So here we can change the size of our box. This box will spawn the agents in, which we'll be doing the flocking simulations on. Here's that. The next box we have the animation settings. Let's get rid of that box. We have animation settings, which basically changes the frame length. So you go from anywhere from 1, but that won't be very important, to 1000, and I do believe we can increase this. No, we can't. So the max you can do is 1000 on here. Next we have the simulation settings, which have the goals in it, not the goals, the rules for the simulation. So here we have the 3 basic behaviors that the flocking needs to flock, which is separation, alignment and cohesion. A good one to add on is the outer bounds, so they don't leave the box, and the limit speed, so they don't go too fast and don't go flying out of the box. Next one is the agent number, so this goes from 1 to 200, and I do believe, nope, I have set that correctly, so you can't go above the limit. So let's go for 30 here. And next we have the alignment radius, alignment bias, cohesion radius, bias, the same for the separation. This basically affects the view range for each behavior. In this case, so our cohesion will be quite far up, and then our alignment will be just below that, and the separation just below that. Increase the bias for the separation, so it gets more priority when things are close to it. This will force them away from other voids more. Close that. Next we have the spawn box, which we won't be using, and we will limit the speed to about 7.7. Why not? We'll leave the spawn box for now. We'll leave the avoid settings and the goal settings for now, and zombies voids were not fully implemented this time, so I have taken them out of the build, out of the final build. Just click reset to begin with, just in case anything goes amiss, and here we go. Here is our simulation, and if you press play, they should start moving around. Easy as that. A good thing to do is to, when you first load it up, just go up here to Encloth, and this will be under, I think, any of these actually, and just click give Encloth Mesh or Nparticle a cache. So just select the mesh, not the mesh, the particle system, and create it. And this will then cycle through the simulation and cache it, so you don't need to worry about things being different, and you can just play the animation. This is more useful for when it comes to bigger simulations with lots more voids, because the simulation will slow down with the more voids you have. And it is nearly done, so once this is done we will then just play through it. These voids are given a mesh, which is this mesh in the middle, which is basically just the default which is created, which is basically a cone which has 4 sides, basically a pyramid on its side, and it creates that by default. But you can have a custom mesh very easily. You can either change it in the instance, which in this case you just need to go and select in the Windows outlier, select the Nparticle shape, go to the attribute, and then in here you just add another mesh. If you want to do it like this, or if you just want to do it from scratch, reset the simulation, and we will create a new mesh. In this case we have a square. We'll scale this square down a bit so it's not too big, and then we will rename this mesh to be custom void. The underscore between custom and void, press enter, then press simulate, and now all of your particles have now got the this mesh, and they all work. There we go. We'll do another reset. We will delete the box, and we will now use a spawn box. We can move this around our scene, increase its size, like so, and then all the agents should be respawned inside this box. We can also move the overall box, and this also moves the spawn box, but you can just move the spawn box individually here. Reset, and then if we set spawn, they have now all spawned within this box, and they can leave this box, but then they do have to stay in the overall box due to our out of bounds behavior we have on them. That's a good flocking motion there. Let's stop that, reset. Now let's add our goals. So we can add a goal here, move one here, move one here. Actually, let's move it up there and move this down here. So now the boys will go to this one first because it's the first one in the list. Then it will go to goal 1, and then it will go back to goal 0 and keep looping until you stop the simulation. And let's turn goals on, reset, simulate, and they go up like so. If they don't go through the first time, they do tend to follow the flock first. That's their main priority until they become slightly more separated or pulled away, and then they go back and finish off their list. Like so. Let's reset. Now let's add a void, which is a red sphere. So you can tell the goals are green, the void is red. Let's turn on the setting, which is basically flee target. So this is the target point. When they get close to it, they flee away from it. Let's reset, simulate. So now they will go round it rather than through it, which is why I put it in the way. It's a bit hard to tell in wireframe mode. But they do go round. But now they're avoiding it completely. They're now just going round due to the trajectory they've been put on. There we go. And that is the void and goals. And then you can set up multiple voids. You can also change their radius here, how big they are. You can change this number manually, put it really big if you want. Same goes for the goals. And you can change the bias of them as well. So if we just go back to the void, put the bias all the way up, reset, simulate. Now you should see them really avoiding it. There we go. It's as if they bounce off. They really do not want to go through it. So, but yes, that is my flocking tool, and I will show you next what else I have done as a render for this short tool and its possible use in the future. I will show you that now. Hello. Yeah. So this is just a quick scene where it's already simulated. I have a green screen floor here, And then I go to the camera. This is the view that the player has, or the player, the person, the camera. So this is the camera view, and this is all in a cache, so there's no rendering. So this is why there's a bug here at the moment saying there's something going wrong, when actually it's already cached and there's nothing actually wrong here. And then you render this out into a scene. No, you don't just render it into a scene. So let's just render this frame here quickly. Actually, no. Yes, let's just do that. Let's just render this quickly, show you what it looks like. So that's what that looks like. I have got the wrong camera activated. So let's try that again. Let's go to render camera 1. Let's just re-render this. So this is what you will see. This is what gets rendered onto the scene, and then later on I composite it all together into this. So this is the original scene here, and then I have this scene here. So this, basically this green screen block here is to capture the shadows, and then it is then put onto this image, but this image is actually flat. So to create this effect, I had to draw this plane. Sorry, I had to draw the plane onto in Maya to cast the shadows onto it, and have the right correct camera angle to get to this effect here. But yes, that is one application for my tool. I hope you enjoyed. Thank you very much.